motion deblurring. Suppose there is blur only in the horizontal direction. Horizontal direction. Example, camera pads as image is acquired. Degradation model. G of xy equal to 1 by t integral over minus t by 2 to plus t by 2 f of x minus x0 into t, comma y into dt. Require h of uv for linear filter. G of uv equal to double integral over minus infinity to plus infinity g of xy into e power minus j 2 by uxvy into dxdy equal to 1 by t double integral over minus infinity to plus infinity t integral over minus t by 2 to plus t by 2 f of x minus x0 into t, comma y of dt into e power minus j 2 by of ux plus uv uy vy dx dt. Interchange order of spatial and temporal integration. G of uv equal to 1 by t integral over minus in t by 2 to plus t by 2 into double integration of minus infinity to plus infinity f of x minus x0 into t, comma y e power j 2 by ux into ux plus vy dx dy dt. Fourier transform of f of x not x minus x naught into t y. This is what Fourier transform. So g of uv equal to 1 by t integral over minus t by 2 to plus t by 2 f of uv here e power minus j 2 by ux naught d t dt equal to f of uv 1 by t integral over minus t by 2 to plus t by 2 e power minus j 2 by ux naught of t dt. Here g of uv equal to f of uv into h of uv, where h of uv equal to 1 by t integral over minus t by 2 to t by 2 e of minus e power of minus j 2 by ux naught of t dt. Suppose x naught of t equal to st and st equal to d pixels. Ft of h of xy equal to hat d of x del of y. H of uv equal to 1 by t integral over minus t by 2 to plus t by 2 e power minus j 2 by ust dt equal to 1 by t e power minus j 2 by ust divided by j 2 by us. My integral that is minus t by 2 to plus t by 2. 1 by j 2 by ud into e power j by ud minus e power minus j by ud equal to sin c by ud. Note h of uv has zeros minus a problem for an inverse filter. Motion deblurring with a linear filter. Blur 20 pixels. W of uv equal to h of h conversion of uv divided by h of uv mod h of uv whole square plus h of uv. Okay, here motion deblurring with linear filter. Motion deblurring with linear filter. Okay, compute the FT Fourier transform of the blurred image. Multiply the Fourier transform by the linear filter. F cap of UV equal to W of UV into G of UV. Compute the inverse FT. Application reading number place. Algorithm rotate the image so that blur is horizontal. Rotate the image so that the blur is horizontal. Estimate length of blur. Construct a bar modeling the convolution. Compute and apply a linear filter. Optimize over values of k. F of xy, h of xy, number plate distance, f cap of xy. Blur equal to 30 pixels. Maximum a posteriori map MAP. M for maximum, A for a posteriori P estimation. Generative model forward process. Original f of xy, motion blur, additive intensity noise. For an image with n pixels, write this process as G cap of equal to AF plus n, where G cap of and F are n vectors and A is an n cross n matrix. Generative modeling. In deep learning, goal take as input training samples from some distribution and learn model that represents the distribution. Density estimation, sample generation, uh, density estimation, input samples, sample generation, generated samples, training data, approximately B data of X, generated at a P model of X. How can we learn P model of X similar to P data X? Why generate models? Debiasing, capable of uncovering underlying latent variables in a dataset. Homogeneous skin color boosts diverse skin color boosts illumination. How can we use latent distribution to create a fair and representative dataset? Why generative models? Outlier detection. Problem: how can we detect when we encounter something new or rare? Strategy: leverage generative models to detect outliers in the distribution. Use outliers during training to improve even more. 95% of driving data sunny highway state road. Detect outliers to avoid unpredictable behavior when training. Edge cases, harsh weather, pedestrians. Okay, this one. So here, detect outliers to avoid unpredictable behavior. Latent variable models, autoencoders, the variational autoencoders, VAE, generative adversarial network GANs. What is the latent variable? What is the latent variable? Can we learn true explanatory factors, latent variables from only observed data? Latent variable only from observed data. Autoencoders background, unsupervised approach. For learning a lower dimensional feature representation from unlabeled training data. Okay. Unlabeled data. So, So here in generative model, original f of xy, motion blur, additive intensity noise. Generative model, forward process. For an image with n pixels, write the process as g cap equal to af plus n, where g cap and f are n vectors, and a is an n cross n matrix. Inverse problem. Estimate f of xy by optimizing a cost function. The f cap equal to argument minimum f g of af square. Observed image. This is the observed image. Generated image. Likelihood loss function plus lambda p of f period regularization. Example, p of f equal to del of f square to suppress high frequency noise. Example 3, super resolution. Suppose there are multiple images of the same scene, each displayed spatially. After registration, the samples are not coincident, and this may be used to defeat the Nyquist limit. Initiative model. Initiative model. Treat images as point samples. Low, more images. High, increase resolution, reduce noise. Generative model. Okay. High resolution. Image F. From here, M1, M2, M3, M4, registration, lighting and blur. G1, G2, G3, G4. Low resolution images. Sketch resolution, non-examinable. Estimate the super resolution image which minimizes the error between predicted and observed images. Write the generative model for one image I as GI equal to MI F plus mu I, where MI combines registration, lighting and down sampling. Finally, the generative models of all n images are stacked vertically to form an over-determined linear system. G0, G1 up to Gn minus 1, M1, M0, M1 up to M minus N1. By F plus mu0, mu1 up to mu n minus 1. G of G equal to MF plus mu. Maximum a posteriori estimation. The map estimated has the form f map equal to argument g of mf square likelihood lambda square p of f period. Example, f map equal to argument f g of g minus m square plus lambda square summation over for all xy p of del f of xy, where the period px is defined by the Uber functions. P of x equal to x square if f is less than or equal to alpha 2 alpha mod x minus alpha square otherwise. Super resolution example 1, Mars. 25 JPEG images courtesy of the Mars lander. Images are from different sweeps of a rotating camera. Super resolution result. Original frame, average image, super resolution. 2 cross zoom from 25 JPEG images. Super resolution example 2, car sequence, rotating DV camera. Mosaic. Super resolution result for ROI. 85j by